problem. Anything else? That's it.
We might have to show some weight before we get that out of there. All right, let's do this. We're going to come up behind your set. We're going to support out.
We've sent a lot of missions, we've landed people on the moon, we've orbited spacecraft around the moon, but the part of lunar understanding that we don't yet have is what's inside the moon. So to really understand the moon and understand what makes it special, we need to study what's inside. Well, it's a little bit like doing a CAT scan of the moon, but we use gravity instead of acoustic waves, and it provides us essentially with a picture of the lunar interior, just like you would make a picture of the inside of your body if you were trying to understand what your state of health is. We will have up to 4 cameras on each GRAIL spacecraft that will be used solely for school children to propose targets that they would like to image on the surface of the moon, and they don't have to wait in line until the scientists are done with their experiment, because the 2 GRAIL spacecraft operate by exchanging radio signals. The students' images will be the first priority, and students who participate in this program will be able to get online, track where the GRAIL spacecraft will be progressing over the surface of the moon, and to propose images that will be taken.
GRAIL will improve our current knowledge of the lunar gravity field in 2 very key ways. It improves the accuracy and the spatial resolution on the near side, where we already have some data, but it really takes it to the next level scientifically, to where we can learn significantly more about lunar processes, lunar origin, and the origin of key features on the near side. On the far side, it's an even bigger improvement because we have so little knowledge, and our knowledge of the lunar far side gravity is at very large spatial scales. So we can really make the pixel size of our knowledge much, much better. Rather than tracking the spacecraft with Earth-based antennas, we track it with another satellite. So we put 2 spacecraft in orbit around the moon, and they each track each other. So even when they're both behind the moon, they're tracking each other, and they're telling us what the orbits are doing and how they're responding to gravity variations on the far side of the moon.
One needs a high-resolution map of the gravitational field of the moon to really investigate its interior structure. What's it made of on the inside? In fact, if you want to know what any closed object is made of on the inside, you either break it, drill a hole in it, or try to study something on the outside, forces that are a manifestation of processes on the inside. And it turns out there are 2 forces that are useful for that purpose: gravity and magnetism. The purpose of the GRAIL mission is to investigate the interior structure of the moon. But to achieve that, we have to measure the gravitational field of the moon. So the measurement type is a measurement of the gravity field, and the ultimate scientific product is information about the interior structure.